Guys, and welcome back to my channel. Science is fun. In the last video I talked about motion, that's a part of physics. Now for today's video our topic is light, that is a part of physics. So what is light? Light is a form of energy that's made up of photons. Light is the fastest thing in the whole universe. The speed of light is 299,792,458 meter per second. We can round this to 300 million meter per second so as to remember it, and mostly we write this as 3 into 10 to the power 8 meter per second. Now let's discuss about the sources of light. The sources of light are divided into two main categories, that is natural sources of light and artificial sources of light. So what is natural sources of light? Natural sources of light are light that occur naturally in our nature. For example, you can take sun or stars. Now what is artificial source of light? Artificial source of light are man-made sources of light. For example, bulb, tube light, etc. Now let's discuss about the properties of light. Light has three properties: rectilinear propagation of light, reflection of light, and refraction of light. So now let's discuss about rectilinear propagation of light. So what is this? Light always travels in a straight line in a homogeneous transparent medium. This property of light that states that the light travels in a straight line is known as rectilinear propagation of light. The light only travels in a straight line in a homogeneous transparent medium. That is a kind of medium in which the composition is always equal. Now let's discuss about reflection of light. The bouncing back of light by any surface is known as reflection of light. Because of this property of light, we are able to see everything in our surroundings. And we can also take an example of reflection as like this. The light ray strikes the surface and gets reflected back. So there are types of reflection and laws of reflection that I will be saying later onwards. Now let's discuss about refraction of light. So what is refraction of light? The bending of light is known as refraction of light. When light travels from one medium to another medium, it bends and its speed also changes. When the light travels from a less dense medium to a denser medium, its speed decreases. For example, when light travels from air to water, the speed of light in air is 3 into 10 to the power 8 meter per second, but when the light enters the water, its speed is 2.26 into 10 to the power 8 meter per second. And when light travels from a higher dense medium to a lesser dense medium, its speed increases. Again, you can take an example of air and water. When light is in water, its speed is 2.26 into 10 to the power 8 meter per second, and when it enters the air, its speed changes into 3 into 10 to the power 8 meter per second. So now I'm going to show you a diagram of reflection and the terms used in the reflection diagram. So this is the diagram of reflection of light. As I said the bouncing back of light by any surface is known as reflection. So as you can see here, a light ray is falling on a surface and it's bouncing back. Now let's discuss the terms and I will explain you each of them. So this is the reflecting surface, and while drawing a reflection diagram, we always mention it as smooth reflective surface to show a better diagram of reflection. This is the incident ray, this ray. The light ray that falls on the reflective surface is known as the incident ray. This is the reflected ray. The ray that forms after the reflection is known as the reflected ray. And this is the normal. Normal is an imaginary line that is drawn perpendicular to the reflective surface. And this is the point of incidence. The point where a light ray enters an optical system is known as the point of incidence. And you can see here two angles. The angle formed between the normal and the incident ray is known as the angle of incident, and it is represented by small letter I. And the second angle that is formed between the normal and the reflected ray is known as angle of reflection, and is represented by small letter r. So now let's discuss about the laws of reflection. So the first law states that the angle I is equals to angle r. That is, the angle of incidence is equal to angle of reflection. For example, you can take that if angle of incidence is 30 degree, it is 100% sure that even angle of reflection will also be 30 degree. The second law states that the normal, the reflected ray and the incident ray lies in the same plane. Now I'm going to show you guys the diagram of refraction of light. So this is the diagram of refraction of light. In the diagram of refraction of light, there is the normal that I have explained to you before. That is a perpendicular line drawn perpendicular to the reflecting surface. As of now, it is a perpendicular line drawn perpendicular to the boundary of two different mediums. So in refraction, as I explained you, it is a journey of light from one medium to another medium and the bending of light. So in this diagram, this part is the medium 1 and this part is the medium 2. So as you can see here, an incident ray, that is the ray that falls on the boundary of the two mediums, comes from here and it passes through the boundary and comes to the second medium. And as you can observe, while it comes to the second medium, it bends a little bit over here. And this process in which the light bends is known as the refraction of light. So in here, the angle between the incident ray and the normal is the angle of incidence, and the angle between the normal and the refracted ray is the angle of incidence. But you can see here that the angle of incidence is not equal to the angle of refraction. So we get a point that the angle of incidence is not equal to angle of refraction in refraction. Now I'm going to talk about refractive index. The refractive index is the bending ability of light. There are many refractive index and it depends upon the medium too. So we can calculate the refractive index, that is represented by the small letter n, and the formula is speed of light in medium 1 divided by speed of light in medium 2. And to represent it in variables, we can represent it by n is equals to c by v, where n is the refractive index, the bending ability, c is the normal speed of light, and the speed of light is represented by small letter c, and v is the speed of light in any medium. It can be anything. So now let's see how to find the refractive index. So the question is the refractive index of light in water. So we have to find the bending ability of light in water. So we can use the help of our n is equals to c by v formula here. So as we know that n is equals to c by v, and I said that c is the speed of light, we can put the speed of light in here, that is 3 into 10 to the power 8. And they are asking the refractive index of water. So the speed of light in water is 2 into 10 to the power 8 meter per second. And in order to find all the refractive index, you need to know the speed of light in different mediums. So we'll get that n is equals to 3 into 10 to the power 8 divided by 2 into 10 to the power 8. And we can cancel out 10 to the power 8 and we'll be left with 3 by 2, that we can also write as 1.5. So from here we can get that n is equals to 1.5. So we understand that the refractive index or the bending ability of light in water is 1.5.